This video is an introduction to variation, going over what you covered in Algebra 1 and just a quick introduction to joint variation, which is the new piece here in Algebra 2. So direct variation, you see the snippet here, y varies directly. This is the equation that you should use. You can read this. So the distance that a free-falling body falls varies directly. So we know we're using this equation as the square of the time t. So k is going to be our constant. What is the equation for this relationship? So the distance d varies directly. So k is our constant as the square of time t. So as t squared. And that's all there is to it. Part B of this says the object falls 36 meters. So 36 meters is our distance in 3 seconds. So that means 3 is our time. So 36 equals k times 9, or 9 times k. We're going to solve for k, so we're going to divide both sides by 9. So that gives us k is equal to 4. So that helps us out because now we know what our constant is equal to. So now we want to know how many seconds will it take to fall 100 meters. So now we're putting 100 in for d. And we're solving for t. So we're going to divide both sides by 4. 25 is equal to t squared. We take the square root of 25, which gives us 5 seconds for time. And normally when we take square roots, we want the plus and minus, but because we're solving a word problem, we don't want to talk about negative 5 seconds. So that's the answer to this question here. And now we look at inverse variation. So you should be familiar with this definition here. Here we know that the force required to balance a person on a seesaw varies inversely. So we know we're going to be setting up a fraction here. K is our constant. With the person's distance from the balance point. So d goes on the bottom. So there's our equation for the relationship. In part B, we have a 150-pound person. So that's our force. Is 6 feet from the balance point. So we're trying to solve for our constant so that we can figure out the other part of the equation. So if we're trying to solve for our constant here, we're going to multiply both sides by 6. So we get 900. 6 times 150 gives us 900, so 900 is equal to our constant. So our general equation here is F is equal to 900 over D. So how far is the 120-pound person from the balance point? So we're going to plug in 120 in for our force. So in order to solve for D, we're going to multiply both sides by D. So we get 120D is equal to 900. These cancel out. And now we can divide by 120. And that gives us our distance here is 15 over 2. In terms of a problem, we probably want to know that it's 7.5 feet. Alright, and our joint variation, okay, it's varying jointly. It means that we have multiple things here. Okay, we have two variables or two things that we're talking about. Okay, so here we have the power is varying jointly. So we know we're looking for two things as the resistance R. Okay, so we have to have a constant, our resistance R, and the square of the current C. So C squared. And there's the equation for our relationship. I'm going to move this up here to give me a little bit more workspace. For a 240 watt refrigerator, so that's our power. Okay, remember we're always solving for K first. Has a resistance of 60 ohms, draws a current of 2 amperes. So now we're solving for K. So 60 times 4 squared actually gives us 240. So if 240 equals 240K, K is just equal to 1. So our general equation, you can put the K equal to 1 there, but we really don't need it. So RC squared. So now we want to know the resistance of a 600 watt microwave. So that's our power. That draws a current of, so we're trying to figure out the resistance. That's what we're trying to find. The current is 5 amperes. So 5 squared. So 600 equals 25R. And divide by 25. And so our resistance is equal to 24. Alright, so we're going to be doing more examples with this in class, but what I really need you to know the difference of is direct, inverse, and joint variation. To really know the difference between those three examples, and to know that direct variation means that as one increases, the other increases. Inverse variation means that as one increases, the other decreases. And that with joint variation, that as one increases, that you have two other things increasing. So please make sure that if you're confused about this, please go over it a couple of times so that we can really jump into the examples in class. Alright, I will see you tomorrow.